Framework Math, and we are here again today as part of the launch party for the subtraction book in the series to take a look at some subtraction. So we wanted to come on today and play with numbers a little bit. So we're going to take a look at 500 minus 287, and we're going to look through 5 different ways that we can subtract these besides using the standard algorithm. And I also want to, as we're going through it, kind of explore the idea, why would we do this? Why would we develop this kind of flexibility with numbers? And I think that by the end of it, if you stick with me here, you'll see that a lot of these are actually a lot more efficient than using the standard algorithm, especially for something with zeros. And the flexibility that you develop and the overall number sense serves you a lot better than just knowing how to stack and subtract. So we're going to take a look at what it means to kind of expand our understanding of subtraction and have fun with it. So in my experience, as I've been working with students, I've seen so many times that as those aha moments happen and students really click and something makes sense to them, that's when math becomes fun. So if you have a struggling learner, if you're working with anybody who thinks they don't like math, thinks they're not good at math, I really encourage you to not be afraid to try alternate methods that may or may not be new, but the more that they really can touch math and see math, not just as numbers, but as actual amounts of objects in groups of tens, the happier they'll be because they'll have that confidence about themselves. So I'm going to try to do a super quick run through of these 5 different methods, but I would like to offer that this would be really fun to do as a workshop. So if anybody's interested in doing a more in-depth workshop on this, leave a comment, and I would love to get that set up if there's enough interest. We can do something on Zoom and have more interaction and talk through ideas about this or about the Rec and Rec or anything that is interesting. So for teachers or parents or tutors or anybody who would find this helpful. And then also at the end of the week of my launch party week, we will be doing a workshop for students. So those are always a lot of fun, and I'll have more information about that coming up. Okay, so let's dive in. 500 minus 287. Obviously we could stack and subtract, but we're going to explore new ways. And I have my little intro here. There's 3 kind of telltale signs that your student may be struggling with subtraction. So sometimes it seems like they know what to do, they're fine, they get the right answer, or they may be on the other end and not. They kind of freeze up when they see something like this. So these are the three kind of things to watch out for. When I chose this number on purpose, because anything with zeros, often kids get the deer in the headlight look where they're like, uh-oh, 0, I do not know what to do with that. I don't like regrouping with all those zeros. The second kind of thing that I've often seen with students as high as high school is just the do something method. So you stack them, and then often the subtraction they subtract any numbers they can, irrelevant of which is which. And then it kind of leads into the final thing where the am I right? Where all day long as a teacher I would hear, am I right? Am I right? And it drove me crazy because I wanted the students to have that confidence in themselves. So I don't mind answering that they're right, but I don't want them to need to ask that question. I want them to know that they're right. Okay, so we are here to overcome those 3 problems. All right, so I want to start with 10 frames. And this particular method I call place value 10 frames. So we build a foundation of seeing that how 10 tiny 10 frames in a 10 frame is 100 beads or whatever you have. Shrink that down. Each one of these has 100. Okay, I'll just keep going. We're going to take a look, kind of jumping right into the deep end of that. So they'll need to have that foundation built. But once they do, you can do this. 500. Okay, so that is 500. Okay, so right away we're making it a little more of something that's less abstract. You can literally see 500s there. It's best if you actually have this shrunken down 10 frames, but this will work. Okay, so we want to take away 287. I'm going to pick up the pace, sorry. So we don't have 7, we don't have 80, we do have 200. But if we're doing the traditional way, and I'll get to the point where you actually can go left to right and it makes more sense intuitively. But if we're doing it the traditional way, we don't have 7 to take away. So we're going to have to do this. If they have built the 10 frames within 10 frames within 10 frames, they'll see we can take one of these out, blow it back up again a little bit, because a 100 is 10 tens. And just to say that is not as meaningful as to actually build it. Because when they build it, just by knowing what numbers are and how they're composed, students get so much confidence in adding, subtracting, multiplying, dividing, because seeing and knowing what those numbers are, knowing how to take them apart, rebuild them, is everything you need to know. We just do more with it. Okay, so we still don't have the 7, but we're going backwards with what I explained in the beginning. So you're going to take one of those shrunken down 10s, blow it up, and keep going. Okay, so now we can take away 7. They just see all these individual digits. So you want to keep in mind with an open number line. Now this should not be a first experience as long as they need it, as long as they're comfortable with that, of building that up. But once they have that, then you can advance. This is a more advanced strategy because it's more abstract, but it's very powerful. Even though this is the simplest thing to draw, this is so powerful. And I call this particular strategy mix and match, because we're going to realize that the difference between these numbers is the distance between the numbers. And in my subtraction book, I lead them up through that so that it's a really intuitive development of ideas. But we're jumping in here to the deep end. So we want to find the distance between the numbers. If you realize that, it gives you power over the numbers because you're flexible. So the distance between these numbers, if we just shift the distance down 1, if you've never seen this, this is amazing. We're going to shift it down 1. So we now have 499 minus 286. So in this case, it does make more sense to do this algorithm. So it's good to have a lot more tools at your disposal so you can choose what makes sense when. So this is 3, 1, and 2. So again, we get 213. So that's based on an understanding of an open number line and what subtraction is. The difference is the distance. And then you can just stack and subtract. Okay, now money is fantastic, but again, it shouldn't be a first introduction because you see $100, but that's the abstract number. So again, students need the 10 frames in the Reckon Rec as the foundation. But here's another really neat way to think about that is a good real world example. Let's say you have $500 in $500 bills, literally $500 bills, and you want to buy something that costs $287. Okay, so probably what you would actually do in this case is intuitively go left to right. So these go together. So we'll pay the 200 because that's easy. So we're down to 300. Away 80, and you're left with 20. So you don't really, it's not extra thinking. It's when you get this sense of numbers, it's a lot more intuitive and fun. I think it's fun. Okay, so we took away the 200, we took away the 80. Now we need to take away 7. You still don't have to worry about the algorithm and all that regrouping, because probably you would look at this, and this is always good to let kids go through and see what they would actually do. Don't just jump into telling them all of these strategies. But you could take away 7 from here and see you're left with 13. Okay, so then you can see we have 213. So money is a good way to get past the kind of ritualistic process and just think about numbers intuitively. Now, what we did there technically was left to right subtraction. So let's take a look at what that looks like. So left to right subtraction is decomposing that second number. So we're thinking of this as 200, 280, and 7. Okay, so we will just walk through it. It doesn't technically look like the algorithm left to right, but that's what we're doing. We're subtracting in that order. So 500 minus 200 is 300. That's exactly what we had with the money. 300 minus 80. If kids are good enough, there's a foundation you need to be able to know off the top of your head. But we know that's 220. 220 minus 7 is 213. So again, there's some skills that you need to know, but I'm assuming once they get to this point, they can do those steps at the end. Okay, and then this is a really fun way that I've only learned recently, and it kind of blew my mind that this even works. But this is kind of, once you learn this way, you may never go back to any of the other ways again because it's so simple. Okay, we're going to just decompose these into their place values and subtract them one at a time. Okay, so normally we would say we want to take away 7. Do we have enough? We would say no. But if you think about it, sure, you take away 7, that just means you owe them 7. So we have a -7. So you have to kind of explore the idea of negatives, and then that makes more sense. I hope the green's been showing up. I'll do black marker now. Okay, 0 minus 80. You can just call it a -80. So we'll owe this. We'll have to pay it back later. But for now, we're keeping track of what we're doing. 500 minus 200 is 300. And then this turns into something very similar. 300 minus 80, 220. Minus 7 is your 213. So that was a quick run through, maybe not as quick as I could have done it, but on 5 different ways. There's still more ways to think about it, but hopefully the takeaway from this is that math can be fun when you understand it. It's good to play around with numbers. If you're exploring any of these concepts, start with hands-on. Always move from the concrete to the pictures to the abstract with numbers, and have lots of words in there. I don't often, when we see CPA, people don't highlight the words part of it, but you need to have conversations. That's what really gets all of this to click. And then the final result is often mental math. So once you really get the idea of how these work, a lot of kids could do this as mental math, but there's no shame if you can't. You can still jot a couple things down on paper, but it may not look like the traditional stack and subtract algorithm. So not all of these are in my book, because one of the big points of framework math is that we want to keep it as streamlined as possible and simple. So we definitely have the 10 frames and the number lines, but these 3 are just kind of a bonus we're talking about today. And that is all I have. So I will come back and answer any questions if I see them later. If anybody would be interested in having a slower version of this or of anything else as a parent-teacher workshop kind of thing, let me know and I will get that set up. We will be having a student kind of